Welcome back, I'm that chemist, and today we have a story where a girl got chemicals all over her bra and was too uncomfortable to take it off. She definitely learned her lesson. During a biology course, we had to run several SDS page analyses to look at protein samples. Typically, one denatures the sample with mercaptoethanol, which stinks pretty bad. Yes, so I've heard that this one smells extremely bad. During the lunch break, my sandwich started tasting more and more like mercaptoethanol with every bite. The moral of the story is, wash your hands thoroughly. Hidden moral, stinky compounds apparently taste exactly how they smell. Yeah, I'm fortunate enough to say that I've never tasted any of the chemicals that I've worked with, at least not to my knowledge. If you've ever accidentally ingested some of the chemicals that you were working with, I'd be interested to hear those stories down below. Some mundane products come from interesting processes. When I was working on the Gulf Coast, I would tinker with equipment high above the ground, big distillation columns. One time I was up there and saw a plant 10 to 15 miles away, a white column of smoke followed by debris blasted out of the plant half a minute later. Then the kaboom hit. It looked like a catastrophic sort of thing. Turned out that it was a unit that made linear alkyl benzene sulfonate, aka laundry soap. The sulfonation units were built into bunkers and the blast was directed up and away from the occupied parts of the plant. There were 0 injuries. I've also seen similar construction in the plants that make peroxide initiators. Yeah, hopefully those peroxide plants don't blow up. Anytime I've ever worked with benzoyl peroxide, I've always been a little bit careful because there's several incidents that I've heard of where BPO factories have blown up. Peroxides are definitely a scary one to work with, and working in a factory that manufactures peroxides on a large scale is definitely something I'm not interested in doing. Reminds me of my sister's boss at the lab she works at. He was the sole reason that there's now strict regulations on how to euthanize lab mice. He panicked when his fiancée brought her parents in to see them and threw a live mouse by accident, breaking a 5-gallon glass container of hydrochloric acid. That poor mouse had a very unfortunate fate. Rest in peace, Mousy. I have a few school incidents. This was back in the 1980s, and mouth pipetting was still a standard procedure. One day I was pipetting an NaOH solution. What I didn't notice was that the end of the pipette was broken, so instead of the bulb filling slowly, I got an instant mouthful. Luckily it wasn't strong enough to do permanent damage, but not fun even so. At the same school, the chemistry teacher was having a clean out in one of the stores. One of the things he was getting rid of was a small tank of compressed sulfur dioxide, which he let me have. This is a really dumb teacher. On the bus home, I couldn't resist the temptation and cracked open the valve. Well, that was a novel way to get booted off the bus and told to walk home. That's so stupid. That's just like extremely stupid. Yeah, I don't even have words. I think kids even know better. The last one was an innocuous looking book in the school library titled something like Electrical Experiments for Boys. I think it was originally published in the 1950s. Among other scary experiments in this book contained detailed instructions on how to build a spark coil capable of generating 2-inch sparks, which equates to somewhere around 150 kilovolts. Apart from playing with sparks, the book suggested hooking it up to an X-ray tube that you could get by mail order. How about a mains-powered arc furnace made from carbon rods from old batteries and a salt bath to regulate the current? What could possibly go wrong? A truly different era. Even as a 13-year-old with a love of electricity and making things go boom, that book really made my hair stand on end. Yeah, I really love looking at all those old experimental books that people just gave to kids, and it was like, yeah, it's totally fine. And maybe it was fine then, because people were more well-educated, but parents nowadays don't have enough competence in chemistry to supervise what their kids are doing. So I wouldn't recommend most parents give their kids unbridled access to chemicals because they wouldn't even know what to do with them. Chemistry safety standards are pretty wildly different globally. I was once stocking up on some work-related chemistry in New Delhi, where there's a full-on chemical market in the old city. That's so cool, I can't believe that. I would love to see that. That sounds like Disneyland for a chemist. And a guy asked for and got a kilogram ampule of mercury. If I remember correctly, it cost him $20. He was nice enough to let me hold it because morbid curiosity, and it's amazing how dense it is. I also had to buy multiple liters of trichloroethylene and toluene, and you could just walk up with cash in hand and walk away with bottles full of that stuff. That just blows my mind. Thankfully, most of my work is a lot more chill now, and the angriest thing I've had to deal with is probably dichromates. And that, too, is once in a blue moon. Yeah, this is crazy to me. I can't believe that you could just go as a normal person and buy large amounts of chemicals. I guess there's like natural selection for people who are willing to not do dumb stuff with it. I'm still extremely concerned about it. I've never had a serious laboratory accident in my career, but there's one accident that I witnessed in my lab that stands out. We had a postdoc in my old PhD lab who, for lack of any better term, was a bit of a tool. He was a pretty staunch sexist. He believed that women couldn't grasp stoichiometry since they didn't have the analytical capabilities of a man, and he just had this really cavalier attitude about him. He constantly gave unsolicited advice, and always turned group meetings into these ego contests. Of course, his own attitude carried over into his lab skills. When someone says stuff like this, oftentimes they don't have a valid idea of what they're talking about. Sometimes people are overconfident and there's zero validity to their confidence. My advisor was really hands-on, and he was really adamant about safety procedures and making sure that we avoided any potential potential dangers. Whenever I had to use palladium on carbon, I had it ingrained into my hands that I needed to add it as a suspension in tetrahydrofuran to avoid any sparking. This particular postdoc didn't believe it was necessary and always added it dry to his reaction. I'll just kind of explain this for the non-experts here. So palladium on carbon is a catalyst. Palladium is a really good catalyst. It can catalyze tons and tons of different reactions, and it's essentially the equivalent of a spark. So what does a spark do? Sparks start fires. Palladium is a good catalyst. So if you have a fuel and oxygen present, if it mixes, it can just go on its own. And that can start fires really easily. So you don't necessarily need a spark if you're working with palladium on carbon. It's also worth noting that the carbon is a fuel. So just palladium on carbon in air itself can also create a spark. It's essentially an ignition source. One day, he was running a hydrogenation on a 5-gram scale and was using a 1-liter round-bottom flask to set up the reaction. He poured in his catalyst, and sure enough, it ignited and shot sparks from the neck of the flask like a fireworks show in a festival. Unfortunately, he also had paper towels that lined his fume hood, which were soaked with acetone since he used those to clean his spatulas in his hood. Some of the sparks landed on this, and the next thing he knew, a wall of fire just erupted to about half the height of his hood. He kind of just stood there, with this expression of utter shock and awe, like a deer in the headlights. Like he couldn't actually believe that something that he did went wrong. 2 other postdocs and myself grabbed spray bottles full of deionized water and just hosed down the entire hood. Thankfully, we managed to clean up the mess and close the sash to clear out the fire literally a minute before our advisor walked in. This postdoc walked away from that experience as a changed man. Sometimes it's good if our confidence is actually tested, and we see if we're worth our salt. I had a similar thing once where I added dry palladium on carbon to a reaction in methanol, and guess what happened? The exact same thing. Add it to the flask, foomp! My heart rate tripled, and I never did anything that reckless ever again. I have a few from my time in the lab. We used a lot of piranha solution in my PhD lab to clean glassware that we used for sample preparation. Surface chemistry. We were making various functional self-assembled monolayers for electronics and biosensing. One of my lab mates missed a small star crack near the base of a 5-liter beaker he was using to clean a large batch of glass vials, and the exotherm when the peroxide was added propagated a partial crack around the beaker. When he lifted the beaker to dispose of the now cool acid, the base separated and sloshed the liquid out of the spill tray and over his lab coat and jeans. We shoved him straight into the shower, down the corridor, and cleaned up the spill. Bar a totaled lab coat, pair of jeans, and trainers, he was fine. But it could have been so much worse. We also had a postdoc in the lab that set a new femtosecond pulse laser up, pointing straight at the door with no beam stop. So a laser without a beam dump is actually really dangerous, especially if it's a high-powered laser, because all those photons still have to go somewhere. He was asked politely to reconfigure the kit before someone got blasted like a stormtrooper. Yeah, that makes a lot of sense. That's absolutely terrifying. During a postdoc project, I was preparing a long-chain vinyl grignard that I was going to later add into a wine-reb amide to make a swallowtail ketone. I'd already done the small-scale reaction, and I was scaling up. Stupidly, I didn't scale the solvent volume in proportion to the increased equivalence of the reagent. So when I initiated the grignard with iodine, the reaction exothermed, then boiled, despite being put in an ice bath. The septum in the sidearm blew out, and the reaction mix fired itself up the side of the hood to the top. Despite cleaning, there was the occasional magnesium turning that would plop itself onto whatever you were doing for months after. Moral of the story? Working in a rush late in the evening is stupid. One of my colleagues at work told me a tale of a fridge containing radio-labeled compounds detonating at one of his old jobs. Apparently the lab had to be taken back to bare brick in decontamination. Yikes, those are 2 crazy stories. Yeah, it's important if you're ever doing chemistry on a small scale to slowly scale it up. I was just giving this piece of advice to somebody in the Discord who had a mishap because they did a 10-time scale up from a 10-gram reaction to an 100-gram reaction. It's really important to control temperature effectively when you do a scale up, and you have to do slower addition. So one good trick is to only scale up by 3-fold max, unless you are following a really robust procedure and you know it's safe to do so. So in this case, it's clear why there was an issue. It was scaled up, and they also didn't increase the amount of solvent, so that exotherm became even more problematic. This actually happened today, and it made me think of the Chempilation videos, so I thought I'd share a moment of stupidity. I'm a first-year PhD student and wanted to remove some dichloromethane from a flask containing about 5 grams of product mixed with silica powder to prepare a sample for flash column chromatography. The rotovaps were being used, and I didn't want to wait for them to open up, so I figured I'd try to remove the dichloromethane in my hood. Instead of blowing my air hose over it like a normal person, I decided to set up a vacuum distillation and try to quickly pump off all of the dichloromethane. It was being a bit stubborn for some reason, so I hit the flask with a heat gun for a bit, when all of a sudden, foomp! My fume hood was coated in a fine layer of yellow product and silica powder. Luckily, it mostly went straight up and stuck to the roof of the fume hood, and not out and all over me. Safe to say, I will never try to vacuum distill dichloromethane again. Yeah, it's not the vacuum distillation of dichloromethane that's the issue here. The issue is more that you had a lot of nucleation sites in that flask, and you had a volatile solvent way above its boiling point. You could do a vacuum distillation as long as you had sufficient cooling for your product, But yeah, this is definitely not a happy ending. It's awful when stuff sprays up all over your fume hood, because you can try and get it down, but you can never get it all down, and then it's really easy to accidentally touch it if you're cleaning part of your fume hood. It's a real nightmare when you get a mess like that. So I have a reminder that proper PPE isn't only for chem nerds. Part of my job is mopping commercial kitchens. We use a chemical called walk and wash in our mop water to help get stuff off the floors. It works pretty well, but sometimes you need a little special sauce to get oil off the floor. So one day we mopped the floors using our special sauce, and a pipe springs a leak. We call in facilities to fix the pipe, and the guy that they sent kneels on the puddle and starts working on the pipe. Over the course of half an hour that it takes him to fix the pipe, he's constantly complaining about how much kneeling is making his knees hurt. When he stands up, the knees of his coveralls are blood red because our special sauce grease strip, which is used to clean off baked-on grease from commercial ovens and fryers, is capable of eating skin and other tissues even after being diluted twice. Yikes. Anyways, we call 911 and poison control. Guy is fine and just has massive scars on his knees. That doesn't sound very fine to me. From that day on, anybody who had to get down on the floor in the kitchen for any reason either had to wear knee pads or lay down in a collapsed box to work on. I'd be really interested to know what's in that cleaning solution, because that sounds like quite a hazard to have around food. If it does that to your knees, just imagine what it could be doing to the food in the same room. So that's definitely concerning in my eyes. When I was in high school, I got fuming red nitric acid all over my hands and feet trying to refine silver on my porch. Fingers and feet were splotchy purple for 9 months. My nails were purple until entirely new ones grew out. Yeah, that's really scary. I'm glad that nothing else happened to you. That sounds awful. In the 4th semester, the basic organic lab took place. Right at the beginning, one of the other students in the lab claimed how great of a synthetic chemist he is and has years of experience from experiments on his balcony. So he acted as if the PhD students and professors in charge were mostly equal in knowledge when they were not around. Around comes a reaction involving the reduction of a carboxylic acid using lithium aluminum hydride. In a 3-neck round-bottom flask, lithium aluminum hydride was suspended in solution, diethyl ether, and the respective carboxylic acid was added dropwise via an addition funnel. To drive the reaction to completion, the mixture was heated to slow reflux. Important note, we were advised to monitor the temperature of the reaction in the flask using a glass thermometer and had an ice bath at hand if any signs of sudden temperature rise were detected. Here comes the great chemist, when all of the sudden a few moments later a loud whoop crack boom kind of noise was heard across the lab. His thermometer was ejected like a crossbow arrow from his gas-tight sealed reaction and impaled the side of a fume hood about 5 to 10 centimeters deep. That is crazy. Oh my gosh. Of course he has done nothing wrong and doesn't know of any explanation when he was asked by the supervisors what might have caused this accident. Yeah, it's unfortunate that that guy had to learn that lesson the hard way. It's definitely a bad story. During school, our chemistry teacher told our class a story about an accident when he was a chemistry student. He was conducting some experiment with 2 other students, 2 male, 1 female in total, that included sulfuric acid. One student tripped into the female student with a beaker full of sulfuric acid, which ended up completely spilling over her. They reacted by getting the clothes off of her and showering her with water. However, they didn't take off her bra because they were hesitant about that. The bra ended up melting and burning into her skin, and she had to get surgery to mitigate the horrible scars in that area. So you might think that it'll be too uncomfortable to strip down and get naked in front of your class when you get chemicals all over yourself, but what's even more uncomfortable is when the plastic surgeon has to strip you down naked and you have to be sedated so that you can get surgery done to repair the damage that was done by your analysis paralysis. So if you ever get chemicals on yourself, think about your future and take everything off. Don't worry, you can be stressed and embarrassed about what happened later. That's not a now problem. That's a later problem. Protect yourself, do the right thing, take everything contaminated off as quickly as possible, and always shower and rinse off. Hopefully this story prevents you from making the same mistake that she did. Once in undergrad lab, we had to do a liquid-liquid extraction using dichloromethane as the solvent. My sleep-deprived brain read that as deuterated chloroform and continued the extraction with at least 20 milliliters of it. Oh no! I was wondering why my extraction wasn't working, so I called in a technician for help. When I told him that there was 20 milliliters of CDCl3 in the funnel, he just stared at me. Now I never go into the lab without napping first. So the story here is they used a deuterated solvent, which we normally would only ever use for nuclear magnetic resonance, which is NMR spectroscopy, and they just used it like your typical normal solvent. Deuterated solvents are extremely expensive compared to normal solvents. They just burned through 20 mils of solvent that could have been used for preparing 40 or more NMR samples. So yeah, this is definitely a learning experience. Make sure that you've got enough sleep before doing any lab work. You can easily make mistakes that could harm yourself or others if you're not careful. I just realized that during my childhood, I was repeatedly exposed to ozone. My mother used to use an old Soviet face care lamp which produced ozone whenever it was on, and the smell of it was nearly unbearable after 10 minutes. After about 5 years when I was 10, it finally broke and I was very happy to not smell more of that nasty gas. I don't know how much ozone it produced or if it caused harm, but I hope no other such lamp exists anymore. It also produced a ton of UV light, but I never stood in the way of it. The one thing that comes to mind now for ozone production is some people have bought these ionizing air purifiers on Amazon, and oftentimes what they mean by ionizing is that it produces ozone, and you definitely do not want to be producing ozone in your house. While that might kill bacteria and stuff, it'll also kill you. It's not gonna help improve the air quality of your house. That I can guarantee. If you have an air purifier and you're not sure if it's producing ozone, I would encourage you to look into that and figure it out as quickly as possible. You definitely wouldn't want to be breathing in ozone, and you probably don't want your kids or relatives breathing that in either. I think bleach needs more awareness. Everybody has it in their house, but don't mix bleach and ammonia. It can kill you. Don't mix bleach with vinegar or any acid. It can kill you. Don't mix bleach with peroxide. It can kill you. Don't mix bleach with rubbing alcohol or nail polish remover. It can kill you. Yeah, hypochlorite is really weird because it's relatively stable. I have a bottle of bleach that's like 3 years old and it still works super well, but it will react with lots and lots of stuff, and that includes almost anything you could possibly mix it with that isn't water. So be careful to never mix it with other cleaning products because you probably shouldn't do that. Even if you've been instructed to by a superior, unless you know 100% for sure that it's safe to do so, I would look into it every single time. My supervisor mentioned that there was a fume hood containing, among other things, phosgene in the lab where he did his PhD research, and that the students nicknamed it the Death Hood. He refuses to have anything to do with it to this day. If there was a fume hood in my lab where there was always phosgene, I would avoid that fume hood like the plague. If you like this video, maybe check out one of these other videos. Have a great day.